Hey everyone, welcome to day 3 of summer school. Today we're going to be learning about molar conversions. So in the first day, you guys learned that a mole is just a term that we use to represent a number. And that number is 6.02 times 10 to the 23rd. So in the same way that a dozen is just a word for 12, a mole is just a word for 6.02 times 10 to the 23rd. So because atoms are so small, we use a mole to group them. So that way when we talk about a bunch of atoms, we can say a mole of copper, and we know exactly how many atoms that is. So a mole of copper is always going to be 6.02 times 10 to the 23rd atoms of copper. A mole of helium is always going to be 6.02 times 10 to the 23rd atoms of helium. So whichever element I decide to use doesn't really matter for this. A mole of anything is going to be 6.02 times 10 to the 23rd. So that number that I just showed you, that 6.02 times 10 to the 23rd, we're going to actually be using that now in some math problems. So some of the problems that you guys are going to see will look something like this, where it says how many atoms are in 2 moles of carbon. So I'll walk you through step by step how you do these, and then you can go ahead and figure out the ones on your own. So the first step in any of these problems is we have to figure out what we are given. So in this problem right here, it says how many moles of atoms are in 2 moles of carbon. 2 moles of carbon is our given value. So that's the number it's giving us, and we have to convert from moles of carbon into atoms. So we're just converting units here. So the first step, once you have your given value, so you know 2 moles of carbon is our given, that's our starting point, you're going to go ahead and just write that down over here on the left side. So in this problem, we're converting from moles to atoms, so we're going to use Avogadro's number to make that conversion. So if you have a piece of paper with you, I would just go ahead and set up your problems like this. Just draw this kind of big plus sign, and you're going to start with your given right there. Okay, so in this problem, I'm trying to get from moles to atoms. So in order to do that, we need to get moles to cancel out, and then I will end up with atoms. So it's going to be a little algebra to make that happen. So the conversion factor that we're going to use here is the same one we talked about earlier in the video, is that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So 1 mole is going to go on the bottom here, and 6.02 times 10 to the 23rd atoms will go on the top. All right, so the reason we set it up this way is because you can think about this as a big fraction. So if we start with moles on the top, and we want moles to cancel out, so we have moles up here, moles down here, the unit moles will cancel out. And once those cancel out, the unit we're left with is going to be atoms. So the next step here, you just put this into your calculator, and now is when you're going to bring in the numbers. So you can think about this as one big fraction. So everything that's above this line right here, that's the top of the fraction, and everything below is the bottom of the fraction. So we're going over 1, so there's really nothing we have to divide by. So everything up here we just multiply. So 2 times 6.02 times 10 to the 23rd. So we go ahead and put that in your calculator. And if you don't have your own calculator at home, you can just Google calculator, just 2 times 6.02 exponent 23, and it gives you this. So 1.204 times 10, and the e, so e24 just means times 10 to the 24th. So your answer for this problem would be 1.2 times 10 to the 24th atoms of copper. All right, so for these types of problems, you're really only going to see 2 different versions of this. So you can see the version that we saw last time, where you're given moles and you have to convert to atoms, or you can be given atoms and you have to convert to moles. So this is going to be similar to the last problem, only it's going to be opposite since we're going from atoms to moles. So the first step here is just to figure out what our given value is. So our given 4.02 times 10 to the 24th atoms, and we have to convert that to moles. So because that number is our given value, it's going to go up here in the top left. Right, so in order to make that conversion, we're going to use the same conversion factor that we used in the last one, which is 1 mole equals 6.02 times 10 to the 23rd atoms. All right, so in order to make this one work, we're going to have to do the reverse of last time. So we start with atoms up here on the top left. We need atoms to cancel out. So we're going to put atoms on the bottom. So we have atoms up here, atoms on the bottom. That means atoms cancel out. And that leaves us with moles as my final unit. So if we go ahead and just put this into our calculators, we take 4.02 exponent 24. So that just means times 10 to the 24th. And if we go back to the problem, so we have our starting number up here on the top, and then we have 6.02 times 10 to the 23rd on the bottom. So in the last problem, we multiplied everything together that was on the top. So that's still going to be the case. So 4.02 times 10 to the 24th times 1, and times 1 doesn't really do anything. And then you divide by what's on the bottom. So 6.02 times 10 to the 23rd is on the bottom. So if we go back to our calculators, we can divide this by 6.02 10 to the 23rd, and that gives us 6.67. We can round that to 6.68. Right, so just to recap, everything that's on the top gets multiplied. So 4.02 times 10 to the 24th times 1 doesn't really do anything, divided by what's on the bottom. So divided by 6.02 times 10 to the 23rd atoms. That's going to give you 6.68 moles as your final answer. So every problem that you do on your assignment here is going to be some variation of this. You're either dividing by 6.02 times 10 to the 23rd, or you're multiplying by it to get your answer.